And yeah, so today we'll be doing parts of scientific investigation, some general tips, and then some ACT special math, I guess, really. Just math that isn't on the SAT, but is on the ACT. So scientific investigation is roughly 25% of the questions type in the ACT science section. And this category requires you to understand experimental tools, procedures, and design, which means like identify controls and variables and compare and extend and modify experiments, like predict the results of additional trials. So basically, that's really it for a general description of parts of scientific investigation. And just like, here's some general tips for the science section. So know your ACT passage types. So you have 3 passages which present a series of experiments, and these are called like research summary passages. You have 2 data representation passages which present information about a topic, and 1 conflicting viewpoint passage which discusses multiple theories about a single topic. So a general tip would be to adopt a strategy for each of the 3 types. So as I said before, the ACT science test comes in 3 forms: data representation, conflicting viewpoints, and research summaries. And you'll need to modify your approach slightly for each one because they are all relatively unique, and you could use a general plan for the same one. However, it would be better to modify it for each specific one. So data representation focuses mostly on charts, graphs, and tables. So you'll need to practice identifying variables, units, and trends. The conflicting viewpoints passage typically has no diagrams and is more like the paired passage you would encounter on the reading test for both ACT and SAT. And research summaries describe 1 or more experiments, and you'll need to understand the purpose, the method, and the results for each of these experiments, and know what the similarities and differences are between them. And again, just don't treat these 3 formats the same. They are all different, I guess. So some more general tips. Annotate the passage. As I said in reading, annotating the passage is really useful because it basically doesn't require you to read an entire section of the passage again to understand what it is. Instead, like when you write it down, you'll both get your brain to remember more. And second, if you do forget, you could just look at the general summary of what you wrote on the side. So as you're reading, don't hesitate to like underline, circle, and make small notes in your test booklet. And this type of note taking is a very efficient way to help you stay focused and be on target with your pacing. And noting similarities and differences between multiple experiments will help you when you are asked questions about it. So another thing is to always refer back to the passage. You won't be able to memorize the information presented in the passages. It's just too much and it's overwhelming. But read the passages to understand the gist and the data that is presented, but also move back to the passage to locate information that you need to answer the questions. And memory alone won't suffice, and you might find it helpful to jot down a few short notes on the passage, as I said in the previous tip. Drawing arrows and circling important info is also a good idea. So trends continue. When asked about a data point, 1 second. It seems like there's some tech errors. All right, now some people messaged me about some tech errors. 1 second, let me just fix this. All right, so yeah, so jot down a few short notes on each passage and draw circles around important information. So trends continue. So like when you're asked about a data point that's not explicitly shown on a table or a graph, you can assume that the trends point presented in the passage will continue. And you can use this to like extend the line or estimate the value of a new point. And like you can draw it out in your test booklet. There's like no rule saying that you can't draw stuff in your test booklet to help you solve a problem. No commonly used terms. So some commonly used terms are independent variable, the variable that scientists change on purpose, dependent variables, the variables that scientists are measuring, constants, the parts of the experiment that the scientists keep the same, direct relationship, as the independent variable increases or decreases, the dependent variable does the same. Indirect relationship, as the independent variable increases or decreases, the dependent variable does the opposite. And have like an overall exam strategy. So like when tackling the ACT science section, ask yourself, what did the scientist study and how did they do it? Why is the experiment set up this way? What is measured? What is controlled by the scientists? What did the scientists find? What are the patterns? And what are the similarities or what are the differences? The halfway mark is it's about 17 minutes. So you should be done around 3 passages and around 20 questions at that point. And circle detailed words in the question stem, such as like not, experiment 1, table 1, just so you don't look at the wrong, I guess, data when you're going through the passage, because you will be in a rush. I almost certainly guarantee that, and you might read something wrong because you just didn't see it very clearly. And above all, pace yourself and strive to complete each passage under a certain amount of time. So like next time you take an ACT science practice test, like set a timer and see if you can like stick to these checkpoints. So like the ideal timing for the actual exam is at 0 minutes, just start your clock and begin. At 6 minutes, finish your answers for passage 1. For 12 minutes, passage 2. 18 minutes, passage 3. 24 minutes, passage 4. 30 minutes, passage 5. 35 minutes, passage 6. And if there's 7 passages in a section, which sometimes does happen, you'd want to spend a minute less on like the shorter passages with fewer questions to have more time for the 7th passage. All right, any questions about what I just told you guys? Again, here is the link for today's slides, if you guys want to look at it yourself. Now let's go on to interpretation of data. So interpretation of data roughly accounts for 40 to 50% of question types. And this category asks you to manipulate and analyze scientific data presented in scientific tables, graphs, and diagrams. For example, like recognizing trends in data, translating tabular data into graphs, which basically tabular data means like you're given a table with numbers in it or something like that. Interpolate and extrapolate and reason mathematically. So some tips for data analysis: read the labels. A lot of people ignore the labels and go straight to the questions, and you shouldn't do that. Mentally categorize like each graph, chart, and table. For example, this is a chart that shows like the relationship between time and distance for various light waves. And don't skip like the statistics entirely and go straight to the question. While maybe you'll think this will save you some time, it's actually a significant decrease in your accuracy. Data analysis questions are like an open book test. You wouldn't skip an ACT reading passage, so don't skip the data. Make sure you read every tiny piece of writing on or near the data, including titles, the labels for the X and Y columns, and column names, and even footnotes, because all of these are important information that could be used on the question. Look at the units. Once you understand the labels, take special care to note the units: miles per hour, miles per second, centimeters squared, other forms of measurement. Are we dealing with seconds, minutes, hours? Does one graph represent the month of June while the other graph represents the entire year? The units may change from graph to graph, chart to table, and some ACT science questions might ask you to do simple conversions, such as like between minutes and hours, or minutes and seconds, or whatnot. Look for direct inverse variation. Quickly note the relationship between the variables in each table, chart, or graph. Do they have a direct or indirect correlation? And where does the data spike or decrease significantly? Again, treat the passage like an open notes test. Like one of the most common mistakes in the ACT science section is using the wrong data, because people rush through them as fast as they can to get to the end, since they don't believe they'll have enough time to do all of it. They look at the wrong data when they're trying to answer a question. The data you need is in the passage. You just have to know where to look. Make sure you understand what the question is asking, then stop and consider which table, graph, or chart provides the information you'll need to solve for the correct answer. Harder ACT science section questions will require you to use more than one statistic. Don't rush to this step. The questions may be multi-step, so look closely for the key phrases in the question that refer to the labels that you looked at before. Approximate when needed. So you may be able to like approximate an answer by rounding off numbers for certain questions. Say you have like 36.33357 whatnot. You can just put 33 in your whatever you're calculating instead. But make sure to be consistent in how you approximate, and only do so if like your answer choices are far enough that estimation makes sense. So don't do estimation if your answer choices are like 1.5 and then 1.6 and then 1.7 or something. Look for general direction behind reasoning. So most scientific reasoning goes either from broad to specific or specific to broad. And it can be helpful in certain conflicting viewpoints questions, whether the scientists are using a specific instance to make a generalization, or whether they're trying to apply a generalization to a specific rule. So any questions about what we just went over? No? All right. So now we'll get to ACT math. So matrices. Matrices don't appear in the SAT, but they are, I guess, relatively common in the ACT. So you should know how to do them. On top of just being useful in the ACT, matrices are an important thing in calculus and in pre-calc and calculus, and probably even beyond. So yeah, the word matrix refers to a rectangular looking box filled with numbers arranged in rows and columns. Each number in the matrix is called an element. When it comes to matrices on the test, you really just need to know the basics. First of all, matrices are referred to by their dimensions. Matrices can come in all sorts of sizes. We write the size of a matrices first with its number of rows, then its number of columns. This, for example, the matrice on the right is a 3x2 matrix with 3 rows and 2 columns. Another, I guess, basic matrix operation is scalar multiplication. So you might see a question in the ACT that asks you to do something called scalar multiplication. This means you're multiplying a matrix by an ordinary number, and every entry inside the matrix is just getting multiplied by that number. So for example, if you have 3 times the matrix on the right, I'm not going to read out all of the numbers. You're just multiplying 3 by each of the individual numbers and giving that result as a matrix. Matrix addition. So you might see a question on the ACT on adding or subtracting matrices. Important note, you can only add or subtract 2 matrices of exactly the same dimensions, which means you can only add a matrix of 3x2 with another matrix of 3x2, and you can't add a matrix or subtract a matrix with a 3x2 matrix by a 2x3 or something like that. I am pretty sure you'd learn a bit of matrices in Algebra 2. I know for sure you learn them in pre-calc and calculus as well. You will need to know it, but I'm not entirely sure what Algebra 2 is, if Algebra 2 has it. So yeah, we add or subtract matrices by adding or subtracting the corresponding numbers. The numbers are in the same spot in each matrix. So you have matrix 1 and matrix 2. I'm just going to get my annotation tool. Second. Put this up top. All right. So you have matrix 1 right here and matrix 2 right here. And for adding, what you do is you add this and this, this and this, this and this, and this and this. So you have an entry in each point. So in reality, what you're doing is you're taking this and you're doing 2 plus 3, because 2 is on this over here and 3 is over here. And then your next entry, 3 plus 4, 0 plus 1, and 5 plus 0. And that is the resulting matrix, which is 5, 7, 1, 5. And that's how you do adding for matrices. So matrix addition continued. There's a matrix right there. So notice the size of the matrices is the same, and that each element in the first matrix is added to the corresponding element in the second matrix to get the corresponding element in the third matrix. -3 plus -2 is -5, which is right here. -3 plus -2 is -5. And with that understanding, you can solve for x by writing a simple equation. X plus 9 is equal to 11. Therefore, x must be 2 because 2 plus 9 is 11. All right, multiply matrices. So you can only multiply matrices if the number of columns in the first matrix equals the number of rows in the second matrix. And when we multiply matrices, the product matrices matrix will always have the same number of rows as the first matrix and the number of columns as the second. For example, the product of a 2x3 matrix and a 3x2 matrix would be a 3x3 matrix. So if you were just given this and like this, you could take the fact that this and this, or wrong thing, this and this would be the dimensions of your matrix. That's the simplest way of looking at it. So matrix multiplication continued. So in order to find the entry in the first column, first row of the product matrix, we're going to have to multiply each number in the first row of the first matrix by its corresponding number in the first column of the second matrix and add the products together. So for this section of the matrix right here, what you have to do is 5 times 1, because that's the 2 right here, plus 4 times 1 here to get this one spot. And for the second, for the entry in the second row, second column, we have to do the same thing with the second row of the first matrix and the second column of the second matrix. So again, right here and right here, multiply them together, add them. And in order to completely fill out the matrix, you have to do 9 calculations. But like the ACT is more likely to give you like smaller matrices or matrices with like more zeros in them and ask you to just find one entry in the matrix. So you're not going to have to spend, say, a good 5 minutes just calculating a large matrix. All right, any questions? Also, when I was talking about adding matrices, subtracting is the same. Subtracting matrices is very similar to adding. Instead of adding 2 numbers, you subtract 2 numbers in the same spot. So yeah, any questions? For the people who don't understand the multiplication, I do have some problems there, but I will do one right here. I'll go back. All right. So since people didn't understand how to do the multiplication, so what you do is to get this spot, and you know it's the first position in the first row in the first column, then you multiply what the numbers in the first, you multiply the numbers in the first row of your first matrices, which is 5 and 1, and then add them to whatever what the multiplication of the first column of the second matrices. So say you wanted to get this number. What you do is, since it's a second, I believe, column, and first row, it's basically backwards. So you multiply, I believe, is it, one sec, I'm just thinking. The second column, so you multiply this and you add this together to get the matrices over there. I might have mixed it up. It's been a while since I've looked at matrices, but I believe that's how you do it. So to get this number over here, you do 3 times 6 plus 0 times 2, which is just 12. And so on. For this one, you multiply this. Oh, wait, no, not by this, not that. I did that wrong. You do multiply by this still. So plus 5, 1. So let me just rewrite that since I mixed up my rows and columns all of a sudden. So to get this position, you multiply this by and add by that. So you do 3 times 6 plus 5 times 1. So you get 18 plus 5, which is 23 as your first thing, as your, I guess, number there. Do you still have a question, Veda? All right, any other questions? No? All right. Here is a practice problem. It's simple adding. I'll give you guys a minute to do this. Just put your answer in the format like just put like number A or oops. So there's six numbers, right? Just put your numbers like number 1, 2, 3, 4, 5, 6. Just put them in a row. You don't need to do all the spacing stuff. Oh, and for this one, do all of them, not just the first one. For the people who just joined late, we did a bit more of the science section, and we're doing matrices for the ACT math section. And yeah, I'll give you guys another 30 seconds to do this. It looks like most of you have got it right though so far. All right, so I'll do this now. So what you do is you have two matrices and you're trying to get a product matrix, which is just both of these added together. So for the first position, you do 5 plus 2. For the second position, 2 plus 3. Third position, 0 plus 4, 1 plus 1, 1 plus 0, and 9 plus 2. And you should get 7, 5, 4, 2, 1, 11 as your answer. Does anyone have any questions? No? All right. Next question. Here's another one. I'll give you guys 2 minutes to do this. A minute to do this one. Also, after you guys finish this, I just realized I explained multiply matrices wrong entirely. I got confused about matrices since I haven't worked them in a while. I will go back and redo the multiplying matrices slides since I did mess that up. But it looks like most of you have got this right. And I will quickly answer this before going back. So you have -10 plus -1. You have 12 plus 4, -6 plus 22, 3 plus 7, which is -11, 16, 16, 10. Any questions for this about this question? No? All right, I will go back since I did this wrong. So disregard what I told you before about how I got this. So what you're supposed to do, I think the second question explains it better, is to get this position, you multiply your corresponding. So you have your column, your first section of row 2 by your second part of row 1 to get together. So to get, I guess, how to explain it? To get this, you do 0 times, I believe 1. Or no, you do 0 times 5 plus -3 times 1 to get this position. Because you're supposed to multiply, as someone in the chat said before, you're supposed to multiply the first number from one matrix with the first number from the other, and then do that for the other numbers as well, and then add the products. So basically, you're supposed to take the first number from the row that you're supposed to go from. So this is the second row, which corresponds with the second row here. And for this case, the third row, you take this row here. So you take the first number, and the column is the last column. So that's the same thing here. So you multiply 3 by the first number here, which is 1, -3 times 1 right here, plus 0 times 5 right there, because you're taking the equivalent positions, I guess, for the different types. And then you're adding these together to get -3 plus 0, which is just -3. Sorry for explaining that bad before. I haven't worked with matrices in quite a while now. It is not 0 times 1, because again, you're supposed to take the first one. If you look at the problem, the one I already wrote before. So if you take this one has 0 times 3. 0 is the first position here, 3 is the top, and 2 times 6, 2 is the second, 6 is the second. And similarly, you do 3. So I have a couple multiplication of matrices coming up ahead, ones I did look over and I remember how to do. So I will explain these again in a problem that I have in a bit, but let's just do subtraction first. I'll give you guys a minute to do this. All right, I see 2 different sets of answers. I think I know why some of you got it wrong as well. Remember, this is a subtraction sign, not an addition sign. Don't just add the matrices, subtract them instead. Again, always remember to actually read your question carefully, because the sort of error that some people made in the chat is something that could happen on the ACT, and that would just not be nice, because this is practice and it doesn't matter if you get it wrong. However, in the ACT, you have to be careful because it actually does matter. All right, so for this one, you do -6 minus 3 to get the first position. So you get -9, 5 minus -2, which is 7, because 5 minus -2 is just 5 plus 2. 0 minus 0, 0. 2 minus 1, 1. 3 minus -1, 4. 1 minus 8, -9. And that is your answer. All right, I'll give you guys 2 minutes to do this one. This is scalar multiplication. If you look on the slides, if you go all the way up, I described how to do this. And if you don't remember, I will do this after some people get it. All right, I'll give you guys another 30 seconds. All right, so the way you do this problem is technically just -3 times the matrix of -4, -2, 2, 7, 1. And the way you do a number times a matrix is you multiply each of these by this number. So for the resulting matrix, you do -4 times -3. Yes, so ACT allows a calculator for the entirety of its math section, while the SAT only does it for one of its math sections. So you do -3 times -2, 7 times -3, -3 times 1. And that would give you 12, 6, -21, -3, which most of you have gotten. Any questions? No? All right. Here's another scalar multiplication. This time you're dividing instead of multiplying. All right, another 30 seconds. All right, so for this one, what you do is instead of multiplying each of the individual values by a number, or I guess you could still multiply, you're dividing it by 3 because it's 1/3. So you do -42 divided by 3, 27, or 27 divided by 3, and -3 divided by 3. So you get -14, 9, and -1 as your answers. So -14, 9, -1. All right, now we have a multiplication problem, which I will actually explain correctly this time. 1 second, my annotation tool. And yes, you can just multiply by -3, 1/3, which is the same thing as just dividing by 3. So it doesn't really matter which way you do it, but that would give you the same answer regardless. So yeah, the way to do this problem is since you want P, so we'll just get P as a whole first before we find the individual value. You can get like the individual value P of the first row and second column, but I'm just gonna do P as a whole because I need to explain how to do a matrix multiplication without messing it up like last time. So you can start by labeling the rows in matrix M and the columns in matrix N. So and columns would be N1 is right here, N2 is right here. That's a 2, not a 1. And you have M1 is right here, M2 is right here. So the simplest way of writing this without actually solving it would be to get each of these, it's M1 times N1. And then you have M1 times N2, M2 times N1, m2 times n2. And each of these, remember, you have to multiply each of these over. So you do, one sec, let me just think. I've successfully confused myself. 1 second. How do I explain this? Here, I'll just write out. I don't really know how to explain it very well, but I'll just write out what I get from that. So you get 2 times 4 plus 8 times 6 plus 3 times 2, because 2 times 4 times, you have 8 times 6 and 3 times 2. And then this is for this. And then for the second one, it's 5 times 4 plus 4 times 6 plus 1 times 2. So 5 times 4, 4 times 6, 1 times 2. And that gives you the first two. And then for the second two, it's 2 times 1 plus 8 times 3 plus 3 times 4, because you have 2 right here. I'm just gonna erase all of these marks. You have 2 right here. Whoops. 2 times 1, 8 times 3, and 3 times 4. And then for the last one, it's 5 times 1 plus 4 times 3 plus 1 times 4. And when you do all the math, you should get 62, 62, 38, 46, 21. Did I explain it better now? I feel like I explained it really badly the first time I did this. And now that we have all 4, even though you don't really need all 4 to find P of 1 of 2, the answer to part A is 38, because in row 1, this is row, column, row 1 right here. And then column 1 right here, or column 2. And then the number that's there is 38. All right, any questions? No? All right. Next question. I'll give you guys a minute to do this, or 2 minutes to do, a little bit longer to do this. Also, this right here is a period. It is not another multiplication sign. Just disregard this. Again, just put your answer in the chat after you finish. One second. All right, do you guys need more time still, or should I solve it? just put in the chat if you need more time, or should I just get to solving it now? Although from the people who did solve it, a lot of you have got it wrong. Although I can kind of tell why too at the same time. For the people who did get it wrong, you guys missed one step. You guys just multiplied the equivalent spaces and you didn't add the other part, I guess. But yeah, you guys need more time? All right, give you guys another 30 seconds. All right. So I guess the best way of explaining this. So first thing we do is you label the rows and columns of matrix 1 and matrix 2. So you always label the rows of 1 is x of 1 here and x of 2 for the rows. And you have y of 1 for here and y of 2 for here. And a general formula to remember is to get matrix multiplication, you should do x of 1 times y of 1, x of 1 times y of 2, x of 2 times y of 1, and x of 2 times y of 2. And the x of 1 and all x of 1 is x of 1 times x of 1 times y of 1 is the same as 4 times 2 plus 1 times 5, because you multiply 4 by 2 and 1 by 5. Since it's a first column and first row, multiply this over. So these two get multiplied together and get added to what these two multiplied together is. So that's x of 1 and times y of 1. X of 2 times y of 1 is 2 times 2 plus 3 times 5. That is right here, because you have row number 2, which is 2 and 3, and you're multiplying by column number 1, which is 2 and 5. And so first of column 2, row 2 multiplied by first of column 1, and you have second of column 2 multiplied by second of row 2 times second of column 1, and that's what you get there for x of 1 times y of 2. You get 4 times 8 plus 1 times 4, and for x of 2 times y of 2, 1 second, that is 2 times 8 plus 3 times 4, because again, you multiply row 2 by column 2 and I guess like the equivalent places, so first by first, second by second, and whatnot. If you do all the math, you should get 13, 19, 36, 28. For the people who got it wrong, do you guys understand why you got it wrong? And what step you guys skipped? Whoops. Yeah, you guys did. You guys got, yeah, that's what I understood as well. You guys, so for the people who got it wrong, from what I can tell, you guys just did this part and forgot about this part entirely. Is that right? I do not believe matrix division is on the ACT, simply because I don't, matrix division is on the ACT. I don't remember it being on the one time I took it. Same with online as well. I haven't heard of it being on the ACT, so I don't expect you to know it. But again, this matrix division maybe could be useful for your math at school. So it might be good to learn it. Actually, no, wait. No, there is no such thing as matrix division. I just remembered. There's a reason why I don't remember it at all. Matrices don't have a thing called division. It just isn't an operator for a matrix. There is a thing called the inverse of a matrix, but that's not on the ACT at all. So you don't really need to know it for right now, but that will be in your math classes in the future. But yeah, there is no matrix division at all. It just doesn't exist. So you only need to know addition, subtraction, and multiplication. All right, does anyone have any questions about this? No? All right. Next question. I'll give you guys 2 minutes to do this. I'll give you guys a little bit of time to do both of these. Just say like A, parentheses, the answer, and then B, and then give me like the matrix, I guess. While I try to find more problems, since apparently I didn't put enough again. I'll give you guys some more time. You guys still need more time, or should I solve it now? Do you guys still need more time, or should I just start solving it now? All right. So for this question, first thing we do is to find 2, 1. So since we're trying to find f of 2, which is second row of C, and the first column of D, and since we know C is this and D is that, And the first row of the second row of C is this, and the first column of D is this. Second. You can multiply it out by using the same formula as before. So you do 5, 2 times 1, 3, which is just 5 times 1 plus 2 times 3, which is 11. So B. It looks like most of you have got that right though. So for the entire matrices, the way you do this is, again, first thing you do is you label the rows and columns. So you have C of 1, C of 2, D of 1, D of 2. And the general formula again. So C of 1 times D of 1, C of 1 times C of 2 times D of 1, D of C, oh my God, C of 1 times D of 2, C of 2 times D of 2. And when you do that, you get 2 times 1 plus 1 times 3. Okay, no, there's no space there. 2 times 1 plus 1 times 3, 5 times 1 plus 2 times 3, 2 times 4 plus 1 times 6, 5 times 4 plus 2 times 6. And when you do all of the addition and multiplication, you get 5, 11, 14, 32. And it does look like most of you got that answer. Oops. How did it do that? All right. Yeah. Any questions? No? All right, next question. I added one more problem. Just 1 second. Go back into slideshow. We should be able to see it now. There. I'll give you guys a couple of minutes to do this. I'm not entirely sure if problems like this would appear on the ACT. However, it is good practice for matrices, being able to do multiple different operations with matrices on one equation. And yeah, I'll give you guys 2 minutes to do this one. Do you guys need more time? All right. So I will start doing this problem now. So first thing you do is you do a scalar multiplication. So you have 3 times 4, -2, 1, -7. And when you do scalar multiplication for it, you get 2, 3, -6. 12, 3, -6, -21. And then you multiply by 4. So you do 4, -4, -4, 8, 32. No, that's bad math. 4 times 6 is 24 times -20. So you have your two matrices here. And now you subtract these two. So you get 12 minus -4 is 16. 6 minus 8 is -14. 3 minus 24 is -21. And -21 minus -20 is 1. And that is your answer. Any questions? No? I have one more, I guess, problem. Let me just put this in here. And then we'll do some science passages. Oh, nope, that gave the correct answer. I'll do a different one then. Whoops. Give me 1 second. I'll get a different answer. I mean, a different question. All right, yeah, here's a good one. Insert image. All right. This one just tests, I guess, theoretical knowledge of matrices. It shouldn't take too long. Again, just put your answer in the chat after you get it. Again, if you don't remember, I do have the way of figuring that out in one of the previous slides. So if you just look at the slides, you should be able to get it. Again, if you get the answer, just put it in the chat, or if you want me to do it, since you don't know how, I can do it as well. Also put that in the chat so I know when people just want me to do it or if they're not working on it. All right. So the way you do this is, 1 sec. My thing glitched out. No. Right. So first thing you should know in general matrix notation, which is M times Rx of C. Let me just write that down. M times R X C. That shows that the matrix is named M and R is the number of rows and C is the number of columns. And when multiplying two matrices, the number of columns in the first matrix must match the number of rows in the second matrix. And in addition, like when adding or subtracting matrices, the matrices must be of the same solution. So when we're multiplying it, the number of columns and rows must match. Therefore, the answer to this one is, so you have your columns and rows. So wait, no. It is just 3x3 because that has your columns and rows matching. And that's the answer. Because in this one, your columns, rows are matching. Any questions? Or no, wait, no, I did that backwards. That's wrong. I just realized. So since your columns and rows are matching, this and this are matching. However, we want the rows from the first one. Remember, M is rows x columns from the first one and the columns from the second one. Therefore, the answer is P of 2 of 4 because you want the first rows, which is 2 here, and the second columns, so 4. Even though the only things matching are the rows of the columns of the first one and the rows of the second one. So the answer is 2x to the 2x4. Any questions? Oops. No? All right. Now we'll be doing some ACT science. So here is the link for the passage we're going to be doing right now. Do you guys want me to do it with you guys, or do you guys want to do it first and then I'll do it after? Or if you guys just don't care, we'll just do you guys first and then I'll do it after. All right, I'll give you guys so you should take roughly around 7 minutes per passage. So I'll give you guys 4-ish minutes, I guess, to read this passage, and then I'll do it after. I'll give you guys 5-ish minutes, and then I'll do it after. Just tell me when you guys finish reading the passage so I can start doing it then. Or just like raise your hand after you finish reading it, so I know when to start. I'll give you guys another 2 minutes before I start doing it. Again, if you did finish reading it, just like raise your hand or put it in the chat that you finished, so I know that people finished. All right, so passage 4, spent fuel SF is a radioactive waste. A radioactive waste is often buried underground in canisters for disposal. As it decays, SF generates high heat and raises the temperature of the surrounding rock, which may expand and crack, allowing radioactivity to escape into the environment. Scientists wanted to determine which of 4 rock types, rock salt, granite, basalt, or shale, would be least affected by the heat from SF. The thermal conductivity, how well heat is conducted through a material, and heating trends of the 4 rock types were studied. Study 1. 50 holes, each 0.5 meters across and 20 meters deep, were dug into each of the following: a rock salt deposit, granite bedrock, basalt bedrock, and shale bedrock. A stainless steel canister containing 0.4 metric tons of SF was buried in each hole. The rock temperature was measured next to each canister after 1 year had passed. The results are shown in table 1, along with the typical thermal conductivity of each rock type in watts per minute per degree Celsius at 25 degrees Celsius. The higher the thermal conductivity, the more quickly heat is conducted through the rock and away from the canisters. So table 1, thermal conductivity of rock salt is 5.7, and the rock temperature is 110 degrees Celsius. Granite is 2.8 with a rock temperature of 121. Basalt is 1.26 thermal conductivity and had 165 degrees rock temperature. And shale had 1.57 watts per meter degree Celsius with 146 degree Celsius rock temperature after a year. And all of the rock types had an initial temperature of 10 degrees Celsius. So study 2, the scientists determined the thermal conductivity of 4 rock types at a number of different temperatures between 0 degrees Celsius and 400 degrees Celsius. The results are shown in figure 1. This is just like a graph of which the X and Y are temperature and thermal conductivity. And there's a key there. I guess a quick observation is that thermal conductivity for rock salt is a lot higher at the lower temperatures, but gets near the other thermal conductivities at higher temperatures. Study 3, the scientists calculated the temperature increase that would be expected over a period of 100,000 years in each rock type at a point within a site holding buried SF. The results are shown in figure 1. So you have times in years and you have rock temperature increase. So around, I guess, the year 100, it peaks. So it increases the most. It stops increasing. It stops, I guess, temperature stops increasing at around 100 years for all of them. And yeah, that's the passage. So question 1, according to a study, the thermal conductivity of rock salt measured at a temperature of 500 degrees Celsius would be closest to which of the following values? So if you go to study 2, right here. So as the temperature increased from 0 to 400 degrees Celsius, thermal conductivity of rock salt decreased from about like, I'd say 6 watts per minute degrees Celsius to around like 2.2 or 2.0, something like that, watts per minute Celsius. And in addition, the rate of decrease slowed as the temperature increased. So at 500, you would say that it would decrease very less. So you'd say around maybe 2 still, because it was a bit more than 2 at 400. So I would guess, I wouldn't guess, I would assume that the answer for this one would be B. Did anyone else get something different and want to explain why? No? All right. Question 2. According to study 3, if another set of temperatures had been calculated for the time 1 million years in the future, the calculated temperature increase in any of the 4 rock types would most likely be closest to. As you could say before, the increase became almost nothing. The temperature increase became almost nothing at 100,000 years. And in like figure 2, which is this one, like all of the curves start to decrease after 100 years and basically become nothing at 100,000 years. So it would be, I would say, at 1,000,000 years, following the trend from the graph up to 100,000 years, it would be 0, because at 100,000 years, you're already very close to 0, and it looks like it's still decreasing more. So the temperature wouldn't be increasing at all after 1,000,000 years, or it would be really close to 0. Welded tuff, another rock type, has a thermal conductivity of 1.8 watts per minute degrees Celsius at 25 degrees Celsius. If the measurements of the temperature of this rock type adjacent to the SF canisters were taken as in study 1, the recorded temperature would most likely be closest 4. So I guess table 1 shows like how rock temperature varied with different thermal conductivities. And like granite has a thermal conductivity with 2.80 and a temperature of 121, and shale has a thermal conductivity of 1.75 with a temperature of 146. And since like welded tuff has a thermal conductivity between those two, you would say that the rock temperature would also fall between these two values. And the one that does that is D, because shale is 121 and granite is 130, or did I get those 146? Or no, I said those backwards. Shale is 146 and granite is 121. Does anyone disagree with either of my 2 answers over here, or do you guys need me to explain either of them again? Again, if you guys have any questions at all about why I chose a specific answer, just ask it. There's literally no point in not doing it, because again, this is practice. It doesn't matter if you get it wrong, because this is practice. This isn't the actual test. However, if you do get a question on the actual test wrong because you didn't ask a question you had now, that would be unfortunate. And there's really no way to fix it because you just didn't ask. So question 4. According to the results of study 1, which of the following best describes the relationship between thermal conductivity and rock temperature? As thermal conductivity increases, the rock temperature recorded adjacent to buried SF canisters. How about you guys put your answer in the chat for this one, and then I will say my answer after. Okay, just like put your answers first, and then I will say my answer after. Or do you guys need more time to get your answer? All right, doesn't look like many of you are gonna put your answer in the chat, so I'll just say my answer now. So if you look at study 1, the higher the thermal conductivity is, the lower the temperature ends up being. So it would be E. It's an inverse relationship with the higher the thermal conductivity, the lower the rock temperature. So the answer is E for 4. 5, based on the information provided, which of the following rock types would be safest in which to bury SF? Again, just put your answers in the chat. All right, since it looks like no one's really participating with the answer stuff, do you guys want me to continue doing science sections, or should I just completely just do ACT math only? Since it doesn't really look like many of you really need the science section. Hello? All right, I'm just gonna do the rest of today's science section, and yeah. So for question 5, all right, I got one person saying science and math. So if you guys do want both of these, you guys need to participate a bit more, since it is just kind of boring teaching to, I guess, a wall really, if no one talks at all. Is it that like you guys just don't know the answers, or you guys just don't want to put like something in the chat? So if you guys don't know answers, I guess the best way of doing this is literally just looking through the passage and trying to see what you can get from it, and just like trying to interpret the data. I will do the questions, but like at least try if you don't know the answers, even if it is just making an educated guess after taking out 2 of them and just guessing one of the 2 that you have left. But in this case, as some people said, the answer is A, rock salt. And the reason for this is because in table 1, rock salt has the least temperature increase out of all 4 of these. And yeah, that is quite literally the reason for why rock salt would be the best one to bury it in, because it has the lowest temperature and the highest thermal conductivity. So question 6. Which of the following procedures, in addition to studies 1, 2, and 3, would best test whether the amount of heat generated by SF is related to the mass of the SF? So yeah, you guys put your answers first, and then I will do it after. On the ACT, so each problem for the ACT, you have So the answers for the ACT go A, B, C, D, and then E, F, G, H. And I really don't know the reason why, but in the actual ACT as well, it does go like that. So one problem you have A, B, C, D, and the other problem you have E, F, G, H. I'm not entirely sure the reason why, but that's just how it is for ACT. So for this question, I guess like roughly half you got this right. The answer is F. And the reason for this is because to determine like whether the amount of heat generated by SF is raised to like the mass of the SF, the amount of heat generated by the SF should be like, so the heat generated by the SF should be determined as like the mass of the SF is varying. And to do this, study 1 should be repeated because should be repeated like with different masses of SF. So like in study 1, 0.4 metric tons were of SF were tested. So using like 0.8 metric tons of SF would provide like a comparison to determine how the mass of the SF affects the amount of heat generated by the SF. And it's not G, as some of you have it, because to determine like the amount of heat generated by SF, if it's like related to the mass, the amount of heat generated by the SF should be varied. I mean, the amount of heat should be determined like as the mass varied, and varying the mass of the rock types wouldn't indicate how much the mass of SF would affect heating. It would only just vary the amount of mass the rocks have. So do you guys understand why it's not G and it's 8 and it's F? For the people who put G, just like say yes, no. I can explain it again. All right, I will just check if I got these right. That's correct. Right. All right, these all look correct. And yeah, that's really it for today. Again, I would say, since some of you did say you don't know the answers, not just math, also just like look at some science passages, just practice. Again, practice is your #1 helper for both the ACT and SAT. Those are tests that are made for people who practice for them through online free material and understand how they work. It's more of answering the question the way the SAT or ACT wants them answered than actually knowing what the answer to the question is really sometimes. And yeah, it's just review whatever you're uncomfortable with. It doesn't have to be math. And next class we'll be doing data inferences, which is like center, shape of distribution, and spread, and data collection / conclusions. And that's it for this class. You guys are free to go. If you have any questions, I'll be happy to answer them. But yeah, that's really it for today.